Okay, welcome to the Cyber Cossack School from Hackers Arise. Today we're happy to welcome once again Lee Trinity to be able to help us in developing exploits. All right, so exploit development. We really appreciate her doing this for us and for Ukraine. Your dedication to Ukraine and the freedom of the Ukrainian people is definitely appreciated and welcomed, Lee.
My absolute pleasure.
So take it away.
Okay, so let's just jump into it. Just switching over to my working files here. And let's get this brought up. Okay, so welcome to an introduction to return-oriented programming exploitation. So for the next 40 minutes or so, we're going to go over some return-oriented programming exploitation. It's a bit of a high-level topic, but I've broken it down into more digestible for people coming in beginner without an assembly language background. I do plan on putting together some stuff on assembly sometime in the future, maybe after Christmas. So yeah, it'll help out with this sort of stuff. But I think I got it broke down so you guys can clearly understand. Okay, so what is return-oriented programming? Return-oriented programming is an exploitation technique where an attacker hijacks the control flow of a program by chaining together small instruction sequences called gadgets that end in return instructions. These gadgets are already present in the program's code or libraries, allowing the attacker to execute arbitrary operations without injecting any new code, bypassing defenses like non-executable memory, DEP. We bypassed DEP a little while ago. This is another technique to get around DEP because we don't have to put our own shellcode in. We'll build a shellcode inside the binary. Okay, so gadgets. ROP gadgets are small sequences of instructions ending in a RET, or equivalent control transfer, found within a program's existing code or libraries. Attackers use these gadgets to chain operations together, enabling arbitrary behavior in return-oriented programming attacks. So we are going to do some return-oriented programming attacks today. Fun stuff. Okay, so what we're going to focus on, and this comes in real handy in more higher level stuff in ROP exploits. The pop ret sequence. Okay, so when we're in assembly, pop removes the top value from the stack and places it into a register. And you'll see next to the pop, and I'm going to show you where these are inside the binary. But next to the pop, it'll be like pop EBP. So that would take the top thing off the stack and pop it into the EBP or the whatever register. So when we get a ret, which comes after the pop ret sequence, it pops the next value from the stack into the instruction pointer, which is EIP in 32-bit, and transfers control to that address. So what we're going to do today, we're going to find these pop ret sequences within the target binary, and we are going to do a simple print. So we're going to print words to the terminal, and then we're going to use that ret to directly go right to our shell code and take over the computer. So here's a picture or my beautiful diagrams. Never make fun of me in my diagrams. I have no artistic ability whatsoever. So here up on the top is what we did when we bypassed DEP, and the same thing we bypassed ASLR. You have your system exit and bin sh are placed into the return, the arg1 and the arg2. So that's how we got around DEP before. So what we will do today, we're going to put a printf statement over our return address. Argument 1 is going to be the pop ret gadget that I just talked about. Next, we're going to use print1. Print1 is inside our binary, and I'll show you that in a little bit. So what happens is, excuse me, the printf prints the print1 argument here, and then it comes back and hits pop ret. So what happens is pop removes this print1 off the stack, and the ret brings it right to our system. And then, of course, our system executes bin sh and exits. right? So nice and simple. We will get into Pop 2 and Pop 3 RET in this lesson as well. And it's a lot of fun. It's a lot of fun. So now, where do we find these gadgets? We find these in the main executable sections of a binary, which are typically the .text section, which is the program's code, the .init section, which is initialization code, the .plt, which we covered last time with the PLT and GOT tables, which does dynamic linking stubs. And then the .fini, the cleanup code. So those places, if we find a gadget that we can work with in there, it's going to be allocatable and executable. And I'll get into a little bit deeper in this in a bit. Okay, so in 32-bit assembly program, non-executable sections are the .data section, which initializes global and static variables. The BSS, of course, which stores uninitialized global and static variables. And the RO data, which stores constants and string literals. So you might find a great gadget within these codes. You can't use it because it's not allocatable or executable. And I will get back to this slide in a bit. So we will jump right into our lesson. And what I'm going to show you right off the get-go, read ELF experiment 2. Okay, so what we're going to do right now is use this little program called read ELF, and I'm going to show you those sections where we can get gadgets from, just so you have a better understanding. So as you can see down here, allocatable is A, and X means it's executable. So as you can see here with this binary I made for you guys, you can see a lot of it's allocatable. Only these sections right here are what are executable as well as allocatable. So as you can see, these 4 sections here in our file, if we find any gadgets inside there, we can use those. You look at RO data, of course, if we find a gadget within that section, it's only allocatable, it's not executable, so we can't use it in our return-oriented exploitation. Okay? So this is just a neat little program you will definitely be using once you get into further study on exploit development. So if that's clear as mud, let me just skip back to my working files here. Now, so we just had a look at that. So now I'm going to show you just how we can find these gadgets, okay? So what I'll do first is I'll open up our executable, or our C file for our executable, which is right here. And this is what we are going to play with. So now I have some print statements put in just to make it fun. You know, we use some childish language. I love childish language. And here, of course, we have vulnerable function. I wish all the vulnerable functions in the world labeled themselves as such to make it simpler for me. But so we just have a buffer here of 64 bytes. Stir copy, just like gets we've seen before, is vulnerable with no bounds checking, okay? And we have this vulnerable function wrapped into a main function. And I wanted to do that just to show you that just how to get around inside of multiple functions, because all of our other ones have just been basic one function, and that's it. So this is the print statements here. So we'll use these in our ROP. So that's what the executable is going to look like once we get it loaded up. So what I'm going to do now is let's jump into object dump and disassemble experiment 2, and I'm going to output it to output.txt. So this is just object dump, and you'll be using this one a lot. I think I've covered it once before in our classes. So now we have an output of the disassembled object dump. Now this is how you manually look for gadgets, and I want to show you the manual way because we it's too easy to become a script kiddie and rely on a program. but I get too nosy or whatever, and I got to figure out how that program works. So this is how the program this is how the program works. So let's cat our output. And as you can see, it's all a lot of assembly code. So as you can see, the BSS doesn't really have much. We can't do a whole lot there. Let's start looking for some gadgets here. Dynamic section. Okay, so here's our first gadget. So we went over to pop ret, and as you can see, it's in the Vinny section, which is the cleanup section, and it is a pop ret right here. So this is going to pop the first thing on the stack into the EBX and then return to our shellcode. So what I'm trying to show you guys is just how we can control the flow of function, and we can mess with this program without ever putting any kind of our code in it. So this is one here. Let's take a look up a bit higher here. And this is pop 4. As you can see, it's going to pop 1, 2, 3, 4 things off the stack and then return. So of course, if we only want to pop 2 things off the stack, we can just grab this right here. If we want to pop 3 things off the stack, we can just grab this right here. As you can see over here, we have our addresses that we use to call this right here. So this is how you manually find gadgets within the stack program. Let's see if we can see any more right off the get-go, but I think that's the main ones I wanted to show you. We also have ones that move forward of the stack pointer as well, but we won't get too far into that. So I'm just going to leave this open right here and open a new terminal. And let's get over to our working files in day 5. So I'm going to do GDB at this point, and experiment 2. Okay, so I'm just going to jump in right quick here because I just want to show you something ahead of taking this apart. Let's just say breakpoint at main, and let's run the program. Now, I just showed you the difficult way of, of going in and hauling apart. There's programs called one ROP gadget I used yesterday. It does the same thing that I just showed you. But you don't really need to know too much assembly to really pull these gadgets out. Now, the nice thing about when you're learning this stuff and you don't have a strong background in assembly, we can just type in ROP gadget here. Oh, let's run the program first. ROP gadget. And as you can see, that pop ret I showed you is right here. The pop 3 ret is right here. Now, what I'll do is let's have a look at this. It's at 84 BD. So let's go 84. We're closing in. C 84 BD. So that's right over here. And this is the same one we were looking at right there. Okay, so now once you get into the higher level things, and I'm going to show you like just a brief example of this towards the end because it gets out of our scope a bit too far. But with these registers, as the calling convention when you're putting together system functions is sometimes they'll have 3 or 4 arguments that you have to pass to be able to get that system function to go. We're going to simulate it today with print, and we're going to do pop ret, and we're going to do pop 2 ret and print 2 print statements, okay? But this sort of sets you up for when you're trying to make your own shell code, which is fairly simple inside here. You need to know what your registers are doing. So like the sys call number, for example, would always go into EAX. So I had to find a pop EAX return, which isn't right here. But once you get into larger programs, this is a very small binary. Once you get into larger programs, you can really rip this stuff apart and find everything you need to exploit the program. So I'm going to close down object dump. I hope that was clear as it can be. Okay, so let's close this down. And here's our ROP gadget. So as I said earlier too, there's add ESP 12, so it'll be 4, 8, 12. It would be 3 spots to the right. So like if you had a whole bunch of junk things on your stack as you're trying to exploit it and you want to move it, you can add these add ESP functions to move your pointer like and get this crap off your stack, right? So what we'll do, we'll quit this, and now we need to get into the actual exploitation of experiment 2. So what we're going to do, we're going to disassemble it, we're going to figure out where everything is, we're going to overflow the buffer, and then we're going to take the program over. We'll craft our exploit of using print statements and pop return before our system function, and generally have a great time doing it. So gdb/q experiment 2. Okay, so I'm going to disassemble the main function, and as you can see, we have vulnerable function here, aptly named. Like I said, I wish they were all called vulnerable functions. So we also need to disassemble that one there. So I just want to make one with a function inside the main, just so you've seen that it was a little different, because I've failed to do that in other classes. So here's our vulnerable function, and as you can see, there's that stir copy that's vulnerable. So I'm going to place a breakpoint on the stir copy, and B and multiplication table, and there. Now we're going to run it. Let's just put in 12 A's to start, and we'll calculate the size of our stack and get that overflowed in the next run through. So we will find out the size of our stack by using this nifty calculation. I just learned this, so it's so cool. Whoops. ESP, and then divide it by 4. Whoops. 4 plus 4. 4. Okay, so 26. So it's 26 words our stack is. I know I'm going to need at least 3 other places after the stack. So I'm just going to say display 32 words in hex from the ESP. So that's going to be our display. So we are at our first breakpoint. So if I just hit next instruction here, and I can see our 12 only filled up this right here. So 4, 8, 12, 16. So this would be 32. Actually, let's find our base pointer first. So 0, 9, 8. So come down here to the 9, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. So there is our base pointer here. Now, when you check next to your base pointer, it's not going to be the return to libc anymore. It's going to be return to main, okay? So let's just do xwx and have a look at this. And it's returned to main here, okay? So that's just going back to the main function. So that's a little bit different once you get into embedded functions. So I just wanted to show you guys that today. So we have our EBP is right here. So I need 16, 32, and 32. So that's 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76. So I need 76 A's to overwrite our EBP. So I'm just going to continue on. So we will run $, Python-C, print, and I want A's times 76. Let's try that and make sure everything looks good. And next instruction, we're at our breakpoint, and boom. Okay, so print EBP here at 058, so that's right here. So we are good. We will cause the program to crash in good ways for good ways for us. So we have that. So what I'm going to do right now actually is I'm going to open my mouse pad and I'm going to start laying out my exploit. So the buffer of A's we've figured out are 76. Next we're going to need printf function, as I showed you. So what I'll do, let's haul up our little diagram here. And okay, so as you can see, we're going to need printf, popret, and print1 in our first exploit here. So printf, or popret gadget, print1, which was one of the statements. This says fuck off actually. So that's that. We have system, exit, and bin sh for our shell. So what's going to happen, what we're going to do, we're going to use a get the popret gadget. We're going to print fuck off to the screen. It's going to ret then to our system and take over the shell. So, I mean, that would be pretty terrifying if you're sitting down at your your computer and someone says fuck off and pops a shell on you, right? So this is the fun part of exploit development. So now we need to track down these things within our binary. So let's get busy with that. Let me close this out for you. And all we have to do inside our binary, let's find printf. And here's our address for printf to call it. So we take that and put into our exploit here. So we already have print A times 76. Here's the printf. So let's open up ROP gadget. And we need to pop return, which is right here. So let's copy that into our exploit. Now print1, which is within our binary. Print1. Here's our address for that. Okay, our exploit's getting built out. Now we need the system. Here's our system address. And let's print exit. Where's that function? It's right here. So we're slowly building out our return ROP chain here. And basically we're chaining a print function onto a system shell. So that's pretty fun. And then the only one that's different, we have to do find bin sh. And there's our bin sh. And I just want to show you guys one little thing here. And it caused me trouble first when I start doing these exploits. If we go find bin/sh, as you can see, it's a very different address. Bin sh is not the same as /bin sh. And it will not work for your shell. So that's just one of those little hiccups that I ran into. And I'm telling you, so hopefully you guys don't do it. Okay, so we have a good part of our exploit already written out here. So I find these are easier to do in mousepad instead of just a terminal window. So let's start building out our exploit here. So we're using Python, if I can spell it right, and our print statement. So we're going to print A's times 76. Okay, perfect. Now we're going to put in our print function, which is little Indian convention. Let's do 10 04 E6 and B7. So that's our system, or sorry, our print. So used to doing DEP. This is our print statement put up there. Make another word space, 4 bytes. Now we're going to put in the pop ret gadget. So that's D5 and 82 and 04 and 08. Okay, so that's our pop ret. Let's also put in our print statement, which is a curse word because childish stuff makes it more fun. F0 84 04 and 08. And if you'll notice, these stop at 8, so you're only left with 1 digit. So just put a 0 before the 8 and it works out great. So now we have our print statement done. We have our printf. We have our pop ret, and this is our curse word statement. So let me just jump down to another line here and we'll put it back into. So now that we have our print statement done, now the pop ret is going to go to our system. So let's put our system function in. And let's go 10, 33, E5, and B7. And you can see the lack of entropy on a lot of these things, right? They're all B7, right? So it just goes to show you just how small entropy 32-bit really does have. So let's get our exit put in. That was our system. Let's get exit. So exit is 60, 62, E4, and B7. Perfect. Okay, so let's put in our shell. And just remember, binsh is not the same as /binsh, and it will cause you to have trouble. I've been there. So 5D, F7, and B7. Okay, so now let's put in our tick and we'll close it. And everything looks good there. Let's bring this back. Okay, I think everything looks good there in our exploit. Let's copy it. And we'll continue. So let's do run. Let's paste our exploit in here. Okay, so let's go next instruction. As you can see, our 4 ones are all in. Let's lower this down here a bit. Here's our print address, so we can check and make sure it's the same here. So B7E60410, perfect. That's right here. Next is our pop ret, which is 0804. Yep. D5, perfect. Next, we're going to move on to our print statement here, and it's 080484F0, perfection. Our system shell, B7E53310, looks great. And our exit, B7E46260, perfection. And finally, our binsh, B7F7 5D4C. Everything's looking good. No errors. And I'm telling you, there's a lot of places to put errors in there as you're typing, looking from one place to the other. So let's hit continue. Whoops, wrong window. Let's hit continue. And as you can see, printed to the screen is fuck off. New process 518 bin dash, we have a shell. So there we go. That is the basics of using a ROP gadget. So let's get back to what we just did here. And this is what we will do. This is what we did. So we used a print statement to print fuck off to the screen. Then we popped the fuck off the stack and returned to system. System, then this ROP chain, chain together print and binsh. So that is how you chain these things together. So now if we had a function, just say exec CVE, which is system call number 11, we would need to pop that into the EAX register. We would have to do pop 3 because there's 4 arguments. So what I'll do, I'll show you this one. I held it off till a little later here in class, but this is the higher level, one of the higher level parts to it. So like a summary of a gadget chain to get a system bin sh to go off. So we would have to pop EAX ret. We had to find that gadget, and it would load 11, the syscall number for exec CVE, into the EAX register. Then we would have to find another gadget, pop EBX ret, and load the address of bin sh into the EBX, which is the first argument. So the first argument in assembly always goes into the EBX. Then we would pop ECX ret, load 0 null into ECX, which is the second argument. Then we would pop EDX ret, which is load 0 into the EDX for the third argument. And then in 32-bit, we would have to do an interrupt 0x80, which triggers all this and says do the system call. So that's the high level part of gadget chaining. So I hope now, after we went through that, that's a little more clearer, and return to oriented programs a little more clearer. So let's go back to our exploit here, and let's do another one just for practice. So we got fuck off printed to the screen. Let's have a look at our binary again, our C program actually. So let's do print2, which says just kidding. Okay, so we don't want to be too serious or too hacker with our hoodies pulled up and being badasses here. Let's just say just kidding. Okay, so let's go back to our, let's open. Now, the first thing, let's run the program. I'm just going to put in a couple A's here because we need to have a look at, let me just quit gdb/q experiment 2, and we'll disassemble the function. I'm just going to put a quick breakpoint in here, guys, just because we need to find out some more information here in our binary before we exploit it. And we'll do the same sort of process we went through before. So I'm going to run. Now I'm going to type in ROP gadget. So next we're going to print 2 arguments with printf. So we would need the pop2 ret, because it would pop print1 and print2 off the stack and then return the instruction pointer to our syscall, our system function. Okay, so hopefully that's clear. We'll pop 2 ret here. So, and we're going to have to put in print2, and this is just getting you guys used to the assembly side of things, where usually most functions have arguments. I know in C and Python we just hit print and we don't think about what's happening inside the computer, but like on a lower level program like in assembly, you really need to understand the arguments, and this is where the Linux handbook comes in handy. I do have a thing on my YouTube that shows how to do basic system calls. So if you want to check that out, feel free. So let's check out the pop2 ret here. Copy. And let's put this into our exploit. So now we're going to pop 2 things off and return to the function. We also need our print 2. So print 2. And here's our just kidding string, because we don't want everything to be too serious. Oops, fat fingers here, folks. Sorry about that. So here's our print 2. And again, these smaller statements don't have like, it just uses like 8 here at the end. So just make sure you put in 08 before. Okay, so we have a good start to our exploit here. We have everything we need. So So what I've shown you now is how to find all these gadgets and how to string them together. So hopefully this is something new and interesting for you guys. So let's do Python C print, and we need our buffer of 76, which I'm sure you guys can all do now because we've been finding this sort of stuff for the past 5 weeks. And here we go. So let's put in our printf, our first statement. Again, we put it in backwards because a little Indian convention. 04 E6 B7. Sounds like bingo, but it's not. Okay, so that's the first one. Let's do our pop2. So our pop2 ret is BE 84 04 and 08. So that's pop2. Fit in one more here on the top. Okay, so we have our print, our pop2. Now we're at our print 1. So F0 84 04 08. Now I'm going to drop down. Okay, so the print pop2 or print 1. Now we need our second argument for our print, which is going to be our print2 statement. And this is just to get you guys used to arguments and show you guys how to pop things off the stack and then return the flow of function to where we want, which is system shell, of course. 08. Good. So that's our print statements with 2 arguments set up with a pop2 ret, which pops print1, print2 off, and then goes to our system. Okay, so let's get our system set up. 10, 33, E5, and B7. Perfect. And let's get our exit in. So our exit's going to be 60, 62, E4, and B7. And finally, our beautiful shell string, which is 4C, 5D, F7, and B7. Now let's put in our little tick to finish the print statement. Don't know what I was trying there, but let's go back and let's put this all in one line again. Perfect. So let's grab our exploit and let's see if we can make this one work as well. So let's copy this. So let's run our program again. And let's display 32 words a hex from the ESP. Okay, so we're at our breakpoint now in the vulnerable function, the stir copy. So let's hit next instruction. Okay, our 76 A's look good, all the 4 ones here. Okay, so let's get to our print statement. Let me just open up this. Okay, so we're here at our print statement. B7E6 0410. So B7E6 0410. Perfect. Okay, so next to it right here would be our pop ret, which is 08 04 84 BE. Perfect. That's our, or sorry, that's our pop ret 2. Our print one here is F0. That one looks good. And then the second print statement, as you can see, these are at the almost exact same place, right? So we're at FD. That's our 2 print statements. B7E53310. That's our system. Everything looks great so far. Let's drop down a line here. And our exit function for our system call looks good. And finally, our bin.sh. Just remember /bin.sh is what you want. Bin.sh will give you not what you want. Okay, so everything looks really good in our exploit. No fat fingers. There's no errors. Don't appear to be. Let's hit C and cross our fingers here. And as you can see, fuck off. Just kidding. New process, executing, new program, bin dash. So there you go. We just used pop2ret to remove two fuck off and just kidding off the stack after we print it, and then go right to our system function. So that's what we were set out to do today, was learn how to take these gadgets and control the execution of flow within a binary program. The cool part about it, we didn't use anyone else's code. I'm like 99% sure, like, the days of shell coding are almost gone. You really need to start building the shell code within the target systems. And once you execute these get past antivirus and stuff too, because it's not looking like the code's already approved, and this code getting executed doesn't come across as foreign code or anything, right? So that's something for you guys to think about. Now, I have uploaded the binary to my GitHub. So for some learning for yourselves, what I would like you guys to do is do a pop3ret. And this one gets nice. We got fuck off, just kidding. We did pop1, pop2ret. Do a pop3ret on your own and bring up love you as the third argument. So that's the homework I'm going to send you guys away with. It's been an absolute pleasure to be here with you guys again for a good 45 minutes here. If there's any questions, I'll take any questions on this stuff here. Just checking the chat. Everything went really well today. Really, really well. Okay, there don't seem to be any major questions here in the chat. I hope it was clear as can be. I will be doing a bit more ROP programming over the next little while, so I can pop back and tell you guys in a while some new things, but that should get you started and started thinking about, hey, I can build shellcode inside people's binaries. So just by using ROP gadgets, which I think are super, super cool. So if there's no more questions, I'm going to hand the class back over to OTW, and thank you guys for your time. And I am constantly thinking about you guys over in Ukraine. I fought a couple wars, so I know what war is like, and it's not pretty. So my thoughts are with you guys over here, and any way I can help out, I'm definitely here to do so. So OTW, I'll hand it back over to you.
Thank you once again, Lee. Great job. Lee, will you be coming back next week?
Yeah, sure.
Okay, we look forward to having you back again. Also, Lee, would you put the link to your YouTube page in the chat for everybody so they can go there and follow you?
Okay, sure thing.
Okay.
Just let me haul it up here.
Okay. I strongly recommend you go to Lee's YouTube page. She's doing some great stuff there.
Thank you so much. So here's my link here, guys.